Hello class, I want to talk a little bit about the metric conversions and the scientific notation that we're talking about in chapter 3 on measurements. Just wanted to put up a little quick instructional in case you're having some trouble with your assignments. Remember, we will need to remember how to do this on the quizzes and on the test as well. Well, let's hit number 1. 3.4 liters, remember that's our basic unit, and we're going to go to milliliters right here. And all I have to do is count how far I went and in which direction. To get from unit to millis, it was 1, 2, 3 places to the right. So I'm going to take that decimal point in 3.4 and I'm going to move it 1, 2, 3 places to the right, remembering to fill in zeros wherever I have nothing there. So the decimal point was at the 3 and it went to the 4, but I have to go 3 places, so I fill those in with the zeros. Same thing on number 6. I want to change 45 meters to centimeters. Again, that is the base unit. So I clear this off so I can start over. That is the base unit. And I'm going to centimeters, and that will go 1, 2 jumps. So that decimal point goes from after the 5, 1, 2 places. I have to fill those in with zeros. So I have 4,500 centimeters. Remember, in number 1 we had 3,400 milliliters because we had to go 3 to the right. Now that works also when I'm going to the left as well, such as with milliliters to meters. Let me clear this off. I'm going to work number 2 next. In number 2, I'm starting with millimeters, and I'm going to meters, which is the base unit. And to do that, I have to go 1, 2, 3 places to the left. So that decimal point that starts here after the 6, well, remember I have to go 1, 2, 3 places to the left, and it's going to end up in front of the 8. So that is 0.876. Same idea. This time I'll leave what I already have up there, switch to a new color so I don't have to erase it again. 11.7 grams is the basic unit, and I want to go to kilograms. In order to do that, my decimal point has to go 1, 2, 3 places to the left. So in starting out between that 1 and the 7, I have to go 1, 2, 3 places to the left. That's going to put in an extra 0 where I did not already have anything there. And then the 1, 1, and 7 will follow. So my 11.7 grams becomes 0.0117 kilograms. And then I can do the same exact thing if I want to do this 78,999 milligrams to grams. Here's milli. And I want to go to the base unit, grams, 1, 2, 3 to the left. That's going to make 7, 8, and the decimal that was at the end will now be here after the 8, 3 places to the left. So 78.999 grams. I'm going to jump down to the scientific notation in just a moment and show you that it's very similar process. When we do the scientific notation, remember we're working with units of 10. Just like we do when we work the metric conversions. So I'm going to scroll on down here to the scientific notation. And my first one says 45,700. I want to convert that into scientific notation. Well, remember the rules. I need the 4, then I need the decimal point, and then I need everything else. Now, in order for that to happen, remember the decimal point started there at the end. What it did is it went 4 places to the left. It's just I don't need to use the zeros at the end of the decimal. Remember, it's always times 10, and since I went 4 places, the exponent is 4. It is a positive 4 because the number I started with is greater than 1. So remember, when the number is greater than 1, your exponent will be positive. When it's less than 1, your exponent will be negative, such as in number 12. I still have to do 9 But remember, that decimal point had to move 3 places in order to get there. And since the number itself is less than 1, my exponent must be negative. So that's going to give me 9 times 10 to the negative third. And it works the same way. Let me jump down here to number 15. Now remember, we don't count how many zeros. So this will not be 24,212 times 10 to the third power. We have to count place values. That decimal has to go after that first 2. And then I need to write every non-zero. And I don't need those last 3 zeros at the end. But my total placement was not 3. We don't count the zeros. My total placing was that decimal point moved from here at the end all the way to after that 2. That is 3, 6, 7 place values. So my exponent is times 10 to the 7th. And the same idea with number 16. It's going to end up after that first 6. And to get it there, I had to go 1, counting the zeros and the 6. 1, 2, 3, 4 place values. But now, since that number is less than 1, my exponent is negative 4. And that's what we're going to do when we convert standard or normal numbers into scientific notation. I'm going to clear this off and scroll down to where we're going in reverse. So if I take this off, I can now scroll down a little further to where I want the numbers that are already scientific to become standard. And in this case, I'm just going to do the opposite of what I did a moment ago. Alright, so I turn on my drawing tool again, and just to do it, I'll pick another color. Okay. Now, look at the exponent right here. That is going to tell you how far and which direction you want to go. If your exponent is positive, you're going to move that decimal point to the right. On something like number 29, where I have a negative exponent, that decimal point is going to the left. Alright, so let me clear this off and we can see what happens. Number 26, 3.825 times 10 to the third power. So I need to move that decimal point 3 places to the right. There's 1, there's 2, there's 3. I don't have anywhere else to go. I don't have any empty spaces I need to fill in with zeros, so this is correct at 3,825. Same idea on number 27, 6.3 times 10 to the fourth. It's positive, so I'm going to the right. There's 1. I still need 3 more to make a total of 4 spaces. That's where I fill in my zeros. And then, of course, we put the commas in place. Now, let me do one with a negative exponent, number 29. Negative 6. Since the exponent is negative, I'm moving that decimal point to the left 6 places. There's only 1 place to go, though. That means I need a total of 6. I'm going to need 5 more zeros. So 0 point. Don't count that as one of your zeros. 1, 2, 3, 4, 5. Then I get to finish the number off. 444. Alright, one more time with a negative exponent, number 33 down here. 8.1 times 10 to the negative fourth, negative exponent goes to the left. I need 4 places, there's only 1, so my other places have to be filled in with zeros. 1, 2, 3, 4. And then I finish off the numbers. Remember, the exponent doesn't tell us how many zeros, it tells us how many place values. So I hope you found this informative and helpful. If you need to see it again, just rewind and start over. If you have questions, make sure you ask me when we get to class. We'll see you in class. Bye.